This video is an add-on to the Just for Fun video 2, introducing a little bit more about uctypes and introducing the concept of function overloading. So since it's been a few weeks since the video, I'm going to do a quick review of where we were. Take a look at this slideshow. The example we were using for uctypes was the GPIO pad control registers, and they are located in the memory starting at address hex 4001 1Charlie00. That was the user bank GPIO, the name of it. The first pad control register starts at offset 4 in there, so its address is 4001 Charlie 004. And so on for the remaining 29 registers. We saw how each pad control register looks bitwise. Looked it up in the manual. To display memory, we have to use some additional functions. You may or may not know about them, but memory access is done through the machine library. We'll be using mem32 since we'll be printing or accessing words, and words are 32 bits, which can also access 16 or 8 bits. Second way is to use uctypes. Here was an example of how to access memory using mem32. You give it an address. This happens to be the address of one of the GPIO pad control registers. It's a word, so we're going to use mem32, and here printing it in hex, binary, or decimal. Warning, printing it in hex or binary produces undesired results if the X value is negative. And here was a way to fix that. Instead of printing the word, print two half words side by side. So when we print the upper half, this is the upper half, shift it right 16 bits, clear out the high order 16 bits, and then and out the high order 16 bits without shifting, or do it in binary so it would get printed correctly. uctypes was analogous to a C structure that you can lay on top of a memory area. We're only going to be laying on top of words. I'm going to be looking at binary stuff. What one of these descriptors looks like is it's made up of a Python dictionary. So there'll be a name field that's the key, and then the value is properties. The best thing to do is look at an example, which we'll do here in a sec, but here are what the properties are. Here's the name field. You can have an offset. You have a description of what kind it is. We're going to be looking at bit field unsigned int 32. Bit field position is given by the least significant bit of what it is you're looking at, and bit size is how many bits it is made up by. We're not going to use offset because offset 0 is what we'll be using. You won't need to put it in. The example we looked at was overlaying a word. A word is 32 bits. The light blue represents the offset from the least significant bit. Dark blue indicates a length. So at offset 0 from the least significant bit, in other words the rightmost bit, for a length of 16, that's the low half of the word. At offset 16 from the low order least significant bit, that's the upper half now for a length of 16. And here's how you overlay the word. Here's the address of the word, and this is what you're using to overlay it with. And then to access the values within the structure, you just use dot notation. So W dot high, W dot low. Compare it to the Min32 way. Now here's something new. The order of the entries does not matter. So in other words, we could have done that word layout this way, put the high order part first and then the low order part. Doesn't matter. Something that was troubling me in the program was I had to have two versions of the detail function that printed values. We'll see why here in a sec. And I wanted to get rid of that. This is the reason, though. Java allows functions to be overloaded. In other words, if you have a function that adds two integers and returns that result, you can overload that function by just defining it again with a different signature number of arguments. That function could call the other one with some specified value given for the value that comes in on the overloaded function. So you can have add function 2,3, which would return 5, add function 2, which would return 7. Python doesn't allow overloading, and this is why I had to have two different versions of that detail function. If you try to do it, like we did there in the Java example, have an add function, try to overload it with another one that would call the first one, Python replaces the first definition with the most recent definition. So there's only one definition after that. Any invocation of this one would give an error. I had to do some research. I'm a Python newbie. And I found out there is a workaround. You can define one add function like this, argument, and then another argument and say the value is none. And then within the function, if the value is none, give it a value. Otherwise, act as if you were the function with two arguments and return the sum. In either case, you return a sum. So add function 2,3 would return 5. Add function 2 would return 7. So these are the source changes we're going to make, but let's look at the source to see what's going on. This was the original program, and what I'm talking about, here was the GPIO PCR layout, word layout. And when we did the detail, there were two ways to call detail, and I did not know about how the overload was done, so I had to have a second version of detail. Take a look at the new function. These comments come straight out of the slides. It begins the same way. Here's the layout of the GPIO pad control register again. At the top is what was in the first function, and here's the definition done in reverse order. Notice all it is, it's the first one going this way. Here's the word layout done the other way as well. These functions, same as they were in the first version, same as they were in the first version. Now the detail function is now there's only one version of it. You give a GPIO number and maybe you pass in one of those layouts. If you didn't pass in a layout, we go get one. And then we have the print only in one place. We look down here, another overload of show worded address and show here's what we show. And we pull up here on the left. This is what the original function displayed, and on the right, this is what the updated function displays, and we see it's the same data. Okay, that was all I wanted to show this time. Thanks for watching.